Hello everybody, and welcome to British Columbia.
What if there was a mass movement of till?
Good question, right.
That was Joni.
No, that's a great question because that does happen. And that's, how would we tell it apart at that point? Like it would have all the characteristics of the original till, and yet we've remobilized it into a debris flow that's...
Not the little scratch, just a big one.
Do you have a big one? If it was what? Okay, awesome. So then we'll have to start thinking about like scale and shape of the deposit. Do we actually see the deposit as something that is kind of localized, or the debris flow, versus till it might be more regional in extent? I want to roll that sucker over.
Ooh, there's just a big deep thing here. Sorry.
Oh, it's okay. There we go. Oh yeah, look at this one. That's a good one. It's got a lot of what we want. So, marks, yeah, some of these are mine, but on the surface of this one are striations. We talked about bullet-shaped boulders in class as diagnostic of till. This may well be one of those. So pointy on one end, often fractured on the front end, flattish top versus a keel-like
Well, you are working today.
bottom part. Okay, so if we're lodging a clast into the bed, and then there's a surface of that clast that stays near the interface with the ice, which keeps moving over it, we'll flatten, we'll abrade, we'll smooth that surface at the expense of the one on the bottom.
Would a till have striations in more of a uniform direction versus a flow?
Versus the debris flow?
Yeah.
Yes. So here's another one of those rules that as soon as you learn it, you learn the exception. We'll say striations occur in till. You look at debris flows, and we know that the rheology of debris flows changes over time. During an event, it can be extremely dense and viscous, and then over time it changes. Some clasts come in contact with each other, so it's possible to create striations in a debris flow. Like clasts that touch each other will have little scratches. But as Matt is saying, in a till we might expect a much more consistent direction in terms of the striations. We'll have to combine it with striations and shape. So we wouldn't create bullet-shaped clasts in a debris flow, unless of course we're remobilizing a till into a debris flow. But then we have another out, which is to think about the shape of the deposit being very much following where the debris flow has gone, right? So if we can tell that, sometimes we can't. So there's no guarantee that we can, we can sort of find an answer out of that, but at least we know logically which path we're going to follow to get there. And so you might expect in the debris flow little scratches in all kinds of directions, rather than pretty consistent scratches on the surface that we can then say, hey, that's, given the shape of the class, that's reasonably the top surface of the class in the bed, and then the ice is moving over it. So I'm not saying it was in its original, this is just coming off the face, but it's probably coming out of this material. And then if we dug one out there, it'd be interesting if you dig one out, we might be able to see some more striations. There's a real mixed bag of, what's that?
Said wink, wink, nudge, nudge.
No, not if you feel, well, here. There's a real mixed bag of lithologies in here, but that one's a bit shaped too. Yeah, kind of. It's getting there. That one. I don't know about the big scratch. I wonder if, oh, it could be. No, it's all right. But there's lots of scratches on it. Yeah. There's a bunch of different lithologies in here. Some gneisses, really, really high grade metamorphic material. And then there's some basalts and there's some volcaniclastics. And so we've got, the right recipe for some rocks being really good at scratching the others. Unlike what we saw, well, in Nanaimo we saw when the basalt is dragged over the sandstone, that works great, but the inverse doesn't produce particularly good striations on basalt. But here we might be able to.
But this is classic glacial till from your experience here in BC, that it's loose, it's unconsolidated, it's not welded together, it's not like a diamect where you're having to just work hard to get anything out of
I think it is a diamect, but it's not over consolidated. Not overly so. Though here I think it's been worked partly. If we went, beyond just the surface sloughing off, I think we might find that it's a bit more compact than what the surface makes it look like. But In the valley here,
Like,
there's,
yeah, can I?
yeah,
Oh, I see. Yeah. It's not as loose as it appears.
the surface is loose, but that's
when you
just
pull
because
one of those out, how hard is
it's
it
been
to just-
excavated and it's also just really wet. And then
I gotcha. Yeah. Thank you. That's helpful.
so we always need the combination of lines of evidence to get to something, right? With some reasonable satisfaction that it's not completely crazy as an interpretation. No, so the shape, the consolidation, the lack of sorting in this case, the striations, the pattern of striations, the striations on different parts of the class, all consistent with what we understand to be happening in terms of process at the bed of the glacier. That helps us make sense of it. If you identify tills because it's poorly sorted and you give it a kick with your boot and it's hard, that's just not really enough, right? So, yeah, I'm sure. Yeah.
So you emphasized this morning that there's not a lot of glacial till in this area, but there's
No.
decent amount here. What's so special about here? Why do you think?
Good
there's-
question. Like we were predicting that we should have till because there's been lots of erosion, and we should have till in the valley fill, and we might have some on the valley sides. And we saw where we were looking on those valley sides, we didn't see much. Squally Point, that big point of land, the Okanagan Mountain that sticks out in the lake, in the bend of the lake, that doesn't have any sediment on it. Literally nothing, and especially till included. But we come in here and there's a bit of till. We're higher than the lake level now. We're into I want to say probably about 700 meters above sea level, somewhere in there. Maybe a little bit lower, 650. So we're above the highest inferred level of Glacial Lake Penticton. And we're also not really so much in the axis of the valley. But what we were able to say this morning is that, most tributaries seem to have had ice in them. And, whether they retreated and produced lots of meltwater beforehand, you assume that they kind of advance. And so in that process, maybe they were depositing till. I didn't mention this, but this is a tributary that goes a long ways up. It's Mission Creek. So I'll show you on a, do I have a DM? I have the big DM. I can show you that.
I can't hold it. What the hell's going on across
Yeah,
the way?
volcanics.
Those are volcanics.
Yeah. Columnar. It's called Layer Cake Mountain.
It is.
Yeah.
Layer Cake Mountain.
What's that? No, the city has spent $4.5 million shaping that face to make it look like an outcrop. I'm kidding. No, I'm kidding.
As a geologist, though, I totally agree.
looks like
It's an art piece.
It looks like an
It's actually rice fields up
It's-
there.
No, that's it's it's volcanic. We talked about volcanics this morning. So let me finish the thought on till, and then we'll go to the volcanics.
I'm sorry, Jerome.
So there's till in some places. There's till, it's seemingly up some of the tributaries. That seems entirely reasonable with our inference that there's ice covering the landscape and producing till. So then the question is, why don't we have the same till down below? And one of the possibilities that we discussed is that maybe you've removed large amounts of it or reworked it as part of maybe what becomes the gravel, the sand, and perhaps even some of the sand and silt that we saw in the cliffs, right? So closer to the lake basin where you may have had water moving through, either that water we said could be in front of the ice or could be under the ice, maybe that's where you rework a lot of the sediment and you kind of selectively strip off the till, but it was there at some point, some amount was there, and you've just reworked it. Up here in the tributaries, you're away from those areas where there is, pretty energetic flows, and so you're preserving till selectively is what it comes down to.
So in that case, could we go down like into the deltas where you have the big coarse gravels and boulders and look for tool marks and stuff on the glass to sort of associate that with the till?
You could try, though. When you look at the class, we drove by some of them. If you saw them on the way to Kelowna, a lot of them are really rounded.
Yeah.
So any shaping that might have been glacial has sort of been overprinted by a shaping that's glacial fluvial or fluvial from water transport. So yeah, it would be interesting to see if we have reworked till into outwash, which we're really coming down to, then maybe some lithologies that are a bit harder or aren't transported as much preserve, the inherited glacial signature, even though they're being overprinted by glacial fluvial process. You'd have to look at a lot of rocks and I know, terrible. So till does exist, like in this valley. It's just, it's not everywhere and not consistently in all the same places. So those are certainly, so that's a good question, Kai. The shaping of the class, the alignment of the striate, that's certainly what we associate with the lodgement process. But we were, last week, we're just getting into those subtleties of saying, hey, what happens if you take a lodgement till and you deform it? You could have class with lodgement characteristics and, you know, some deformation that remobilizes them so they're no longer in their original lodged position. The only way you would get at those questions, you'd have to do what we'll do next week, is do fabric measurements, but also look carefully at the orientation of the class when they're in the face and in the exposure, not just rolled off and then we just dug it out. You want to see when they're in situ, is the kind of keel-like bottom on the bottom, or is it flipped upside down, right? Is the inferred top actually near the top of the deposit, or is it sideways or something like that, right? And again, through the accumulation of the notes you make and the observations you make, then you can say, yeah, I'm pretty, you know, think it's a reasonable interpretation to call it lodgement till with the class still in their lodged position. If you did that class fabric and you had a fabric that was, you know, kind of going all over the place in terms of being kind of bimodal or even kind of girdle-like, like, that's not really what I expect out of a lodgement till. I expect something much stronger. Then if you've got evidence or data on class orientation and arrangement and position, even better support the argument that it's not a primary lodgement till. It might have been reworked, remobilized, and deformed a bit. So we're back to the VARF thing. Like, there's no smoking gun, ever. There's always a combination of things that come together.
Like going through like a flow chart to try to figure it out. You'd have to be just ticking boxes and
yeah,
trying to get the closest sort of
thing that would, yeah.
fulfillment.
Yeah. So first till, first exposure to till, and first till exposure. Maybe first exposure to till, I don't know. But Tuesday we'll see some more around town when we go measure. Somebody.
Somebody had to do it.
Back door, sir. On the way out.
Yeah, I guess our candidate's being selected.
All right. So volcanics. Yes, we talked about volcanism in this valley, right? This Eocene rifting. So I right now cannot remember if that is Eocene in age or not. It might be a little older. I'm not sure, but I think it is. But that's called Layer Cake Mountain. You have what?
I have the geology map on my
Well, pull it out and see what, or pull it up and see what's. That one. Oh, no, not right. I should.
I've never seen anything like that.
All the terraces are a natural feature.
So I've read different things. Some people have argued or interpreted initially that these are individual lava flows, right? But if you go up close and if you look, after I tell you, if you look, there's very strong columnar jointing, but the jointing goes through multiple layers, suggesting that in fact this is not individual lava flows, because if they were, we might expect each one to have its own set and pattern of columnar joints, but in fact is one or very few lava flows, and the jointing cuts through multiple of these layers of the cake. It's called Layer Cake Mountain.
It is
Now,
Eocene.
Eocene.
Yeah.
It is.
Eocene.
Okay.
God.
Thank you. And so then what produces that layer cake? I don't know. I'm not sure. Something internal to the flows, but pre-cooling, because then we're making columns that go through multiple layers.
Thank you.
You can kind of see some of that if you look at the joints. In places you can see fairly clearly, maybe around when we go back to the bus, if you look across, you can see some of them go through multiple.
That's cool.
All right?
Very cool.
Yeah.
Good. So we're taking the materials off. The varves, the lake sediments, the tills, the outwash, the cakes, the layer cakes, the volcanics.
Take the cake.
All right. So let's go to the bus And then I was going to go down into the canyon and look at some gravels, but we're going to see some more somewhere else. So, and I think there's a couple of people that have hurt their knees, so we won't go for a hike. We'll go look at some other landforms. Yes?
How much of the land is covered by till?
How much of it?
Yeah,
I don't know. Not much. And if you and if you find some, again, it's sort of up high on the sides of the valley. It's not blanketing everything.
It's not?
No.
What other soil types?
What, you mean soils or actual sediments?
Just this area, or you're meaning in general?
Yeah, like in Nanaimo, for example.
Oh, in Nanaimo.
Yeah,
Oh, in Nanaimo
like
we have
when it's
till.
not-
Yeah,
okay,
there is
it's
till.
there.
Yeah, and at many other places there's till.
Yeah.
But in the valley here, there are big areas that have no till.
But I don't really understand. Like, I know Sweden, it's like
Everywhere.
I
know.
Everything is till.
You go on the Laurentide in Canada, there's till everywhere.
Yeah.
Unless there was a big lake there that made some mud on top, but they're still underneath.
Yeah.
Yeah.
But if there's been like multiple glaciations,
Yeah.
it should be.
Lots of till.
Yeah. In my mind, it's like it should be like a blanket of till
Yeah.
everywhere.
Yeah, that's right.
But I don't understand how it.
So we've reworked a lot of that till into outwash, probably during deglaciation. We're also in an ice sheet compared to the what you have in Sweden or the Laurentide, where there's a lot of relief. So whatever water you produce will naturally funnel and is high energy, and so its ability to rework the sediment, I think, is pretty high. And so you're going to turn that till into outwash pretty efficiently, I think. But the bigger, we had exactly sort of these questions this morning because, like you're saying, if there's been multiple glaciations, why don't we just have multiple blankets of till? And we don't really see the till in the fill of the valley, that 600 meters of sediment. There's no real obvious unit that acoustically on seismic looks like till. Why not? Like you said, you'd expect one because wherever you look, otherwise, and on the bed of ice sheet, you do have some till.
Yeah.
Is it just really thin? Is it being reworked as it's being deposited? Has it been kind of just eroded completely, selectively in some parts of the valley? Or the point of the across from the campground, it's just rock.
Yeah.
It's smooth, it's sculpted, it's got channels cutting through it, but there's no till. And, okay, if you're in a location where you abrade and erode, you won't get till right at that spot because you're busy scraping.
Yeah.
But somewhere not far, typically you find that there's deposition. Right? As soon as you get a bump, you get a low pressure, you can have some till. And gradually you build a blanket of till. You don't have the blanket of till.
Yeah. That's strange.
Yeah. No, we call it a sediment. Yeah, or a material. Yeah.
Oh yeah. So soil types are.
Soils are like podzols and other.
Yeah.
Yes.
Okay,
Yeah.
The words are confusing.
Yeah. Some people call till soils, but that's not right. Like soils are really,
Yeah.
where there's been interaction of the substrate, which might be till, with vegetation and leaching and water and transformation of the, chemical reactions that lead to the, yeah. Oh yeah, scrape your boots. That's a good one.
Oh yeah.
So there's big boulders of basalt there, just at since we're looking at whatever's on the roadside. Basalts, there's a basalt by the post over there. They weather kind of gray, brown, blue, but wherever they're cracked, you can see how mafic they are, well, being basalt. But and this one, I don't know what that one is. It's just like looks like a breccia. It's got little laminated units inside it, but they're all fractured. So maybe it's a volcaniclastic unit of some kind, or some sort of. It looks almost like it's a lithified but debris flow unit or something where you've just incorporated pieces and they're fractured, and you can see they're dislocated down here at the bottom. Some small ones encased in. I'm not sure what that is. If it's volcanic, might be volcanic.
I mean, look at the variety.
Yeah.
I assume they pulled it out right here.
Yeah, that's just out of the ground here, and there's tons and tons of it.
My God. Holy shit. Another one? Volcanic?
Yeah, that's volcanic.
Uh-huh.
I mean, they're almost rhyolitic or something.
They sure are.
Yeah, some of these purple ones are.
They sure are. Boy, what a stop.
Oh, the good striations on
What
this
a
boulder.
Stop, I'd say so.
Look at that. That's a good one. That's nice. Beautiful ones. Yeah, look at that chunk, eh? That's nice.
I thought Washington was Disneyland for geology.
Well, Disneyland just continues north. It's bigger than you thought. There's a whole other parking lot at Disneyland that you didn't know about.
This is the land of tomorrow.
Many of these are really, these volcanics preserve striae really well. Behind Janina, there's a couple of big boulders where you see really nice striae on them.
Because if it wasn't nice, all these would be like.
Is this a? That's a vein. These are veins in the gneiss or in the metamorphic rock. So the striations. This one's really hard. But over there, where Jordan is, we can have a look. I can show you. Because, I mean, the surface is smooth, no doubt. But we're just not seeing the striations that well. This basalt has them pretty well. This one, this volcanic even better. Like you can see these grooves. These are kind of like the ones we saw on the sandstone outcrops that day when we went out and measured striations, remember? Okay. And you can see them curving around the class a bit. And you can usually tell if they've been gouged by an excavator because it's just a really big, a great big chunk taken out or a big scrape. Yeah, it might be because they move them around, you know, they clamp them down. And.
Are we saying those striations formed when it was a boulder?
Yes, I think so.
I've only seen striation on a big bedrock bench
Yeah.
or something. But
No, I
this
think
is-
most of these were boulders in the till. And we're seeing the striations from when they were boulders, not when they were in place and then were later ripped out with the striae already attached. Because the striae wrap around pretty much many
That's
of
what
the
I'm
sides.
saying. Yeah, that's so weird.
Like this one, you can really see how this went around, you know, the shape of the class, the shape of the boulder.
When they're like lodged in the bed, Jerome?
Yeah, lodged in the bed or close to the interface with the ice, and they're being dragged along. And once you lodge them in sediment, then the ice still moves over them, right? So you'd striate them pretty well.
That's brand new thought to me. Huh. I think it is, yeah. It's like a museum right here.
That big purple one? Yeah, watch your eyes. Yeah, safety squints.
That's a pretty one.
Yeah, some of these are fantastic. Just a little bit higher,
Actually,
hard to pack
This
home.
one's super cool too. Is this all like xenolith? This lighter gray? It's really kind of got melted into the other stuff.
I don't know what that is. These, I thought these were fract. No, I think these are scraped probably from.
Scrapes?
Oh, this. No, I
Like,
thought
see
this.
this?
This. Yeah, I don't know. I don't know what that is.
Scrapes.
What do you think it is?
I think it's like xenolith that has
Yeah.
been like somewhat melted into the new stuff.
Volcanics then, or something, or plutonics, or a mix of both, one intruding the other. I mean, it looks porphyritic in parts. These, or are they? Maybe I think it's a little bit ferric.
This one probably has.
This one's porphyritic basalt. Really good. Phenocryst, isn't it? Yeah, see more of this breccia business here.
When you come back in 2 years, you're going to have to find these in people's backyards. 'cause
That's right.
This is
They'll be on the front
neighborhood.
lawns. They'll be wrecking the landscape
Oh,
and getting to
good
them.
God, look at this.
Yeah.
Canyon Creek Estates, now available.
Yeah, these are pretty cool.
I'll say it again, I'm just stunned that they're not all basalt, or they're not all
Yes,
magnetite, or they're
right.
not all whatever. Like
Yeah.
everyone is, they didn't move them in here. They had to have found them here.
Oh no, they're in here. There's no
Yeah.
doubt. They just pull them out of the,
Yeah,
because they can't run them through the crushers or the sorters, right? They just
right, right.
and they use them to make kind of these retaining walls, but
And they're sub-rounded too. I mean, they've been,
some of them, yeah.
they've been kicked ass over tea kettle.
So some of these may have been like maybe the more angular myelinite gneiss types might just be derived real close on the hillside, because that's what the bedrock is. But some of the other ones, I mean, the basalts might be coming out of who knows where. There's some basalt, you know, there's those Chilcotin basalts that covered the
Right.
plateau areas, so it'd be easy to move them around. And the breccias, you know, they're the Eocene, I think, breccias and or you know, volcaniclastics that come along with these.
Yeah.
So they're potentially dispersed in multiple places. $240.
Good Lord, it just gets better and better.
Yeah, that's folded. That's beautifully
Chevron
folded.
folds in this
Yeah,
stuff.
from this side here, on the other side of it, you see the folds, you know, along the axis, rather than through the top of the. All right, why don't we move on to our next stop? Unless there's other rocks to look at, but we'll see more. These are good. I'll open the bus. Yes. This one? I don't know. I see it everywhere, but I just can't tell.
I think it's conglomerate.
You can go. Probably volcanic,
Okay,
I would guess.
viewers, I'll give you the phone number. You better call now. This episode brought to you by Canyon Creek Estates. You gotta love it.